Want to welcome everyone to this session. This is kind of a continuation of some of the AI-focused webinar series that we've been hosting recently. Thank you for spending a part of your day with us. My name is Tim Kramer. I'm a Business Development Director here at Lean Techniques. For anyone who is unaware of Lean Techniques, hopefully you know us a little bit, but we are a software and technology consultancy. We're based in the Midwest, and our mission is to help organizations make technology a competitive advantage. And right now, we're doing a lot of work alongside teams locally to help them adopt these agentic-first ways of working, to kind of increase what they're seeing from a productivity and experience what AI ROI can really look like. We are also a GitHub partner, a Microsoft Solutions partner across data, AI, and app innovation. These partnerships will really allow us to help provide our customers with access to resources and capabilities. Next. Without further ado, let me introduce Scott Sauber. Scott is our Director of Engineering and a Microsoft MVP. Scott advises clients large and small in technical strategy, architecture, and organizational design. Scott works with teams every day to help them adopt these agentic-first approaches that we're going to be talking about and show them how to deliver software better as a whole. He's an international speaker, Microsoft MVP, Dome Train author, Redgate community ambassador, and co-organizes both the Iowa Code Camp and .NET user group. Scott, thank you for being with us today, and take it away.
Cool, thanks, Tim. All right, just to level set, because you all are taking time out of your day, so just wanted to level set to make sure you're in the right room. Really want you, when I built this talk, I had a couple different audiences in mind. Really, it's just people using Copilot today. But honestly, even if you're just using AI in any tool, not even Copilot, Claude Code, or any others, a lot of these same techniques still apply. There just might be some nuances in how you apply those. So hopefully you're trying to maximize your token usage at the end of the day. We're just going to take some brief time to level set real quick on like what tokens are. I'll actually go into some decent amount of depth about what are tokens, because I think understanding those is useful if you're getting into AI. Talk about what changed with GitHub's pricing on June 1st. I'll talk about what the impact of that was, and then a bunch of different strategies for minimizing token use while maximizing outcomes. And I'll talk a little bit more about that. But I think this is a trap that some people fall into, especially with these changes, is, oh, I'm going to use AI as little as possible now because it costs me more money. And I think really you need to be thinking about how do you maximize it, not how do you minimize it. So just getting into that mindset shift, but we'll talk about that a little bit later. Okay, so what are tokens exactly? Really, it's probably one of the most critical fundamental building blocks of AI. And what you can think of is, let's say you're in Copilot or ChatGPT or anything else, is it's going to split up your prompt into what's called a series of tokens. And you can kind of roughly equate this to like 4 characters per token. So if you have an 8-character word, it's going to split that into 2 different tokens. Now that's not a hard and fast rule because each model does things a little bit differently, but that's kind of a general rule of thumb that is in the industry, and you can kind of use to think about this. But there are 2 different types of tokens. There are input tokens and there are output tokens. So input tokens are what you might expect. It's what you input into the system. So it's like your prompt, your Copilot instructions file. There's also like a system prompt that each tool, such as Copilot, has. All of these things go into the models themselves, and that costs you money, as well as when you get output tokens. So when it's taking that input and providing a response and performing actions and things like that, those also cost you money, and those are output tokens. So those are kind of the reads and writes of the system. And technically with Copilot, I'll show this a little bit later, there's 2 different pricing models for input tokens and output tokens, where output tokens are more expensive. And really kind of the way you can think about it from like Anthropic or OpenAI or one of those perspectives that are actually providing you the models is the more tokens you have, the more processing there is. Therefore, it becomes a cost unit for them. Models can also only handle so many tokens at a time. So if you've used like some of the Anthropic models, like Opus, for instance, that has a 1 million token context window. So as your conversation gets larger and larger and larger, and you're having it do more things in the same session, eventually when you get to like 900,000 or so, it'll do something called compacting, which basically takes your 900,000 tokens, and again, those are just a bunch of words at the end of the day, and compacts those down and summarizes those down into maybe 1,000 tokens. But obviously, you're going to lose some nuance and things like that because you're literally taking a bunch of words and summarizing it, just like a human would. So, but models do have some of these token limits where they can only handle so many at once. So if you've got this prompt saying AI is unbelievably fast, it will break this up into different tokens and then assign an integer to each one of those tokens. That's also why, like, there's a famous test out there of how many R's are in strawberry. So you could go to ChatGPT or Copilot and type that prompt, say how many R's are in strawberry, and a lot of times it'll say like 2, or get it wrong in some way. And part of the reason for that is basically AI is it's converting these characters into integers, so it no longer really has the characters anymore, is kind of what's happening under the scenes. So that kind of just goes away. But you can see like in the middle there, it's split up unbelievably into 4 different tokens here. So that's kind of how tokens work at a high level. So here's a visualization. I did create this with AI. This was not handcrafted artisanally with my own hands, because if I did, it wouldn't look this good. But I did direct it and told it what to build. So you kind of have these input tokens. Again, that's like your system prompt, your Copilot instructions file, any skills that you have, your prompt, all of those kinds of things. And that gets fed into the model, which has a context window that starts to fill up over time and translates those input tokens ultimately into output tokens of what you were trying to have it do, like write the code, all of that kind of stuff. But also what goes into those output tokens are like explanations and summaries and all of those kinds of things of like what it did. So we'll talk about a few strategies to minimize some of those explanations, as well as compress some of the input tokens and things like that. So this is just kind of a visual of like where tokens come in 2 different places, the input side and the output side. Okay. So that was just tokens at a high level. We'll get a little bit deeper when we're talking token caching as a strategy, but that gets into just kind of level set on tokens, and hopefully that makes sense. So roughly you can just think of a token is a word, more or less. Now, what changed with GitHub's pricing? Well, if we back up a step, if we think about GitHub Copilot, GitHub Copilot was the first AI assistant that was ever released, which means GitHub themselves didn't really have any idea of how to price it. They didn't know how many people would use it. They didn't know what the cost structure would look like. They didn't know any of that stuff. And so they chose request-based pricing. And now that request-based pricing also had a model multiplier. So if you used a higher level model, it costs you more requests. The problem with that was no matter how large or small the request was, you paid the same price. So if you just said, "What's the weather today?" that was the exact same cost as a 1 million token input of like where you're asking, 50 questions over the course of a day in a single conversation and things like that. Like those, like a 1-word prompt and a 1 million word prompt had the same cost, which from their perspective, the 1-word prompt costs them a lot less than the 1 million word prompt. So now everybody else in the industry, like Anthropic, OpenAI, that has competing products to Copilot, they were aligned around token-based pricing, because ultimately the more tokens you have, the more expensive a request is to process. And so GitHub on June 1st really realigned to how the industry does things and moved to more token-based pricing. Because really, at the end of the day, like I said, tokens drive the cost for the model providers. So tokens are now priced based on input and output and by the model. Now, GitHub also introduced this concept of an AI credit, and really what that is just a bucket of money at the end of the day. So 1 AI credit is 1 penny. So if you have 100,000 credits, you have $1,000 to work with. And again, how many tokens each AI credit gets you depends on the model, the input, output, caching, these kinds of things. So to show an example, if you go to like the GitHub Copilot pricing table, they call it. I just zoomed in on the Anthropic models, and technically they have like 50 in here, but I just zoomed in on the 4 that are the latest models. You can see Haiku there. Haiku is a less capable model, but it gives you fast responses, and it's the cheapest. So it's $1 for input, 10 cents for cache input, and I'll talk about that a little bit later. $1.25 for cache writes, and then $5 for outputs. Sonnet goes up 2x basically across the board. Opus goes up 5x from Haiku, and Fable goes up 10x from Haiku. I notice these cache inputs are all 10% of the regular inputs, and I'll talk about cached token caching here in a second. But this just gives you an idea of, depending on the model that you choose, you're going to burn up more tokens. And this is pricing is per million tokens that you're paying here. So it's not each word costs you $1. It's basically like roughly 1 million words costs you $1. And again, it's not really, token is not one-to-one with the word, but conceptually that's kind of how you can think about it. So what else changed with GitHub's pricing? Well, no way around it. They were really subsidizing the cost for everybody by being on request-based pricing. So what we're seeing across the board is people's bills, if you had the same amount of usage from month to month, your bill went up at least 2x because they were subsidizing you, and now they no longer are. So now it's basically just a straight pass-through. So if you look at these prices out on GitHub Copilot's pricing site and then Anthropic's Copilot pricing site, it is literally 1-to-1. So they are not making any money off of sending the models themselves. They're making their money off of like the licensing and all of those kinds of things. So again, previously they're eating the cost, now it's straight pass through. So how that kind of works is you have a bucket of AI credits, again, just a bucket of money. And then you can assign user limits. So I can tell Kramer, hey, you only get $100 to work with. Meanwhile, I get 1,000 just because I'm going to use it harder than Kramer is. Yep, he's not too happy about it. And I can also set up alerting based on different things. So I can say like, hey, when I've hit my limits or when I'm getting close to my limits, alert me, all of those kinds of things. But basically that bucket is shared across all of your user base. Now you do have autocomplete. So if you're using like the Copilot extension in VS Code or Visual Studio or whatever the case is, JetBrains product, the autocomplete is free, but then if you have the chat or the agents or using CLI or cloud agents or spaces, those are all impacted, which ideally you're using one of those, not autocomplete, because that's where you're going to get the most value out of things, versus autocomplete, while useful, is going to allow you to move as fast as like the CLI and agents and all that kind of fun stuff. So, just want you to think about like, what is your response been? I'm guessing a lot of people on this call are on GitHub today and Copilot. So you've been living this world for almost 2 months now. So I want to think about like, what has your response been? So I've seen a few different reactions to this. Basically, one response is they basically gave everybody, I don't want to say an unlimited budget, but a very high cap that is hard for them to hit because they see the value out of it. And then I've seen companies go the other way where they might give people like $25 or $50 at a time, and you have to like go request more. And, that might take a few hours or a few days for people to up you and things like that. And in my opinion, I think if you're giving people like a less than $200 budget, you're kind of missing the benefits of AI. Like there's pretty much no way you're capitalizing on the benefits of AI. So if we just go round numbers, like $100,000 engineer is roughly $50 an hour, but you tack benefits onto that. It's roughly 30% more with benefits. So it's roughly $63 an hour. So basically a $200 a month budget breaks even if it saves that engineer 45 minutes a week, which if you haven't experienced this, agentic coding can take a multiple day task and turn it into like a 1 hour task. So you can basically make that up immediately. You can basically make up the time savings with one simple task that you're saving yourself with. So just kind of be thinking about like you might be optimizing like a $200 line item inside of a $10,000 one, with that 10,000 being like the, fully loaded salary with benefits and all that kind of stuff. And that's, again, not going extreme on that salary or anything. But of course, if you don't, like, you might be thinking to yourself, well, I'm not going to give them a budget because I don't actually think my engineers are utilizing AI well. Well, that's part of why LT exists. So if you're interested in us helping your engineers utilize AI better, come talk to us. All right. So that was just kind of level setting on like tokens and then also like what GitHub did. So now let's talk the meat of this presentation, which is how do we get the most value out of our tokens that we have? Because ultimately, again, we want to make sure we're using, now that GitHub's not eating the price for us, we do want to make sure we're being responsible with our token usage and not just having an agent run for days on end, spending tens of thousands of dollars or anything crazy like that. All right, so there's really a few different strategies. First one's context management. Second one's token caching, model management, effort management, and then I'll talk about a couple tools. One's called Headroom, and then a couple skills called Caveman and Ponytail. So I'll talk about all these different things in a lot more detail, but just to give you a high level of kind of what I'm going to be talking about, that's what I'm going to be talking about. All right, so let's first talk about context management. This is honestly the biggest lever that you have to affect how much money that you're spending. And really, you need your engineers to be managing their context well at the end of the day. Because again, your reminder, your context is like your current prompt plus any prior prompts that you have, plus any prior responses, plus the agent's MD file or Copilot instructions file, plus like the system prompt. And again, system prompt is basically just something built into Copilot, for instance, that instructs Copilot on how to interact with things. So you can't really control that. But then there's also like skills, MCP servers, all of those things ultimately factor into your context. There's also been some studies out there that you want to stay what's called the smart zone and not enter what's called the dumb zone, which the smart zone is basically in a single session having less than or equal to 150,000 tokens. Because once you start to get above that, now like the model has more to like think about, reason about, all of those types of things. Now that's not a hard and fast rule to say, hey, once I hit 151,000 tokens, now I'm gonna like kill that session and start a new one. It's just something to be mindful of, and we'll talk about strategies to be how to be mindful of that. So I keep that in mind. So like I think about like, hey, maybe I should clear my session because I've hit past this capacity. So a few different strategies for managing your context. If you're in like Copilot CLI or the Copilot app, you can do /clear to start a new session, or you could just start a whole new session in the Copilot app. So if you haven't used the Copilot app, you've probably used like ChatGPT, and that session is just basically like a new chat on the left, is what it is. So again, what I find is not enough people clear as often as they should, because they might keep one session going for an extended period of time, even when there's completely unrelated things in that session. Compact, on the other hand, it doesn't wipe everything clear like Clear does. It takes what you have and summarizes it down. So again, if you have 500,000 tokens, it might take that and summarize it down into like 2,000 tokens. So the downside of Compact is when you run it is now it's lost all of that context other than the words that it's summarized. So that's just something you got to be mindful of, hey, you might lose some context as to like how you got some useful context, because basically the tool itself is deciding what it should compact and what it should keep and what it should throw away, all of that fun stuff. Now, this is where, like, let's say you've got a situation where you've got a session open, you had a code reviewed, it got merged, somebody looked at it maybe later that day or the next day, and then they had some feedback for you on things they wanted to change, or maybe they found a bug, and you see that, oh, I've still got this session open. In that case, I would honestly not start, or I would honestly not like say, hey, go fix this bug. I would start a new session and say, hey, I want you to go fix this bug, because depending on how big your session is, you might have like, let's just say 300,000 tokens in that context. And now you're going to send that up to GitHub, pay for pay for that cost and everything, versus oftentimes it's better to start a new session and let the model kind of like discover where the bug's at, versus processing all of your context and hoping that it figures out where that bug is based on everything that you've previously found. Some people are like, well, I'm doing the same thing, so it's already got the context in mind and all that kind of stuff. But as we'll talk about here in a second, your token cache is completely gone, so it's got to reprocess that entire context. There's probably things, if you went back and forth with the agent, that are no longer relevant to the conversation. And maybe your bug is like, literally, I'm just like, doing something kind of smaller, or whatever the case is. Then you probably don't need to like send all that context of your prior session along for the ride. Another thing, and this is guidance that's changed recently, where really you should have less than 100 lines in your like agentsmd, Copilot instructions, Claude MD type files. Previously, you were supposed to have like these big, long instructions files that kind of described where everything was at. But the models have gotten so good now that honestly, you don't need any of that stuff, and it's just bloating your context because, again, every single prompt you send basically copy and paste what's in your Copilot instructions file or your agentsmd file along for the ride on every single prompt. And it's especially bad if it's out of date. Like, for instance, if in your instructions file you say, hey, this type of code is here, like this, our data access is in this folder, but you've like switched that around and now it's out of date. That's really bad for agents because it's got to redirect itself every single time it deals with that. So in general, what they say now is to minimize the amount of instructions that you have because, again, the models are getting so good. And another thing is you can delegate exploration or other types of activities to subagents to keep your context clean so you don't have to pollute your main context. Now, honestly, Copilot and other tools will do this for you automatically by default now. But that's also something to think about is like, hey, do I actually need my main context window to do this? Or can I just like send a subagent on this task and have it report back what it found, like do some research or whatever the case is. But you can use /context, whether you're in the CLI or the Copilot app, to kind of see where your token usage is and evaluate, hey, do I need to remove like an MCP server or skills or like whatever the case is. Now, this visualization shows as you make different turns. So a turn is kind of like when you send a request and get a response back. That's a single turn. So as you keep adding more and more questions, your context starts to fill up more and more. So each one of these green lines is your prompt, your question that you had, and then the blue line above it, blue bar, stack bar above it is the answer and what it did and all that kind of stuff. Well, you can see that gets sent along for the ride as your session grows. So you're paying that cost every single time. So you just honestly, like, managing context is probably one of, if not the biggest things, not only to get like good results with AI, but also to manage costs. And really everything I'm going to talk about from this point on is about managing context. So a couple of different things you can do. So if you don't have a status line in the CLI, you can do /status line. And basically what that will do is allows you to pick different things that is more like in your face of where you're at with your context. So for instance, and your usage. So for instance, this is saying, hey, for my plan for the month, I've used 47% of it. So I still have roughly half of my tokens left for the month. In this particular session, I've used 26 AI credits, which again, each one is a penny. So I've used basically 26 cents of AI credits in this particular session. Also in the bottom right, it'll tell you, hey, I'm using this particular model. And in this case, I've used 10% of my context window. So basically Opus has 1 million context window, 1 million token context window. So I've used 100,000 tokens. So these like two things, if you don't have it in your status line, I would highly recommend adding those so you can be more conscious of how much you're spending, how you're managing your context, and you don't have to do like /context every time to figure out where you're at. You can, or / usage. You can just have that in your face basically at all times. So I highly recommend that. The Copilot app also shows this. So there on the far right, when you type in, it'll say, hey, I've used this much of your plan. And in this session, I've used this many credits. This was kind of fun because technically I sent them an email saying, hey, I want this feature. And they added it the next day. So that was pretty cool that they added it super quick to the Copilot app here about a month or so ago. So again, this is two different ways you can manage your context and kind of have it more in your face and monitor kind of what's going on and what you're doing for spending and all that fun stuff. All right. I'm going to talk about token caching, for instance, which is a pretty deep concept, but I think it's important for people to know. So token caching, basically, as I showed in that graphic before, the model reads your entire conversation on every single prompt. Well, with token caching, basically what it means is if the input doesn't change up till a point, then it can resave that process context and reuse it, not reprocess that entire context every time. I'll show a graphic of this here in a second. And basically that process savings comes from like Anthropic or OpenAI, whatever model you're using, or Microsoft with their Microsoft AI models. The process saving comes from not having to recompute that token into a key and a value that they use kind of under the hood. And that's why if you go back to what I said earlier, that you only get charged for 10% for cached input versus a normal input. So you can kind of think of the analogy like imagine you're reading a book and you stopped on page 300 and then you picked it up the next day. Well, ideally you start from page 300 and you don't have to start back from page 1 every single time and reread it to get all the context because that context is sitting in your head and you can and it's cached in your head. So that's kind of the idea behind token caching is can you pick up from where you left off and read forward, not read everything you did before. So prompt caching only happens for sliding, and the sliding part is important, a 5-minute time to live in memory on their servers. So what that means is every time you send a request, basically adds another 5 minutes where it keeps everything it just did in cache. But the problem is if you walk away for 6 minutes, basically that cache is gone. It's no longer in their memory server side and you're basically hosed. Now this is different if you're using Claude Code. They keep things around for an hour. But for Copilot, they keep things around for 5 minutes. So you don't have to do anything to enable it. This just happens for you automatically. So you might notice, hey, I get a quicker response if I'm like interacting with Copilot, quickly, like it gives me a response and I quickly respond basically within 5 minutes. Most likely what's happening is you're benefiting from token caching. So it's not only going to give you quicker responses, but it's also going to save you money. So what that looks like is when you have turn number 1, so again, the first message you send, it's sending your system prompt, anything in your like agentsmd file, and your message, and there's no cache at that point. And then turn 2, it's caching everything up to that point, other than your reply and the message it sends you back, and then it kind of continues on for there. So again, if you think of this like the book concept, you're picking up where you last left off. The problem is if you change anything underlying, so if you change like the system prompt or you change like your agentsmd file mid-run, basically it's going to break your cache and you're going to end up having to pay for the entire thing. So how do you avoid messing up your token caching? Don't walk away for 6+ minutes. This obviously isn't always possible, but that's one way. Don't change your model mid-session. So this is another... if you've ever tried to change your model when you're mid-session, it usually pops up a warning saying, hey, you're going to lose your token caching. And the reason is the way token caching works is model specific. So it's basically going to blow away any token caching you benefited from. Adding skills or MCP servers mid-session, that will also mess up your token caching. Editing your agentsmd or Copilot instructions mid-session will also do that. Realistically, you're not going to always be able to leverage token caching with Copilot, especially if you've got multiple agents running at once. You're not going to be able to stay on top of them every 5 minutes, most likely. But this is something that not a lot of people know about, so I want you to be aware of and mindful of. So maybe instead of, spinning up multiple agents and walking away, maybe you try and get one down a path and then, you move on to the next one and get the next one down the path. So you still are building up multiple agents, but you're not like delaying how quickly you respond to them because you want to get within that 5-minute window. Lots of different things like that. All right, so that was token caching and kind of how that works. Let's next talk about model management. So the question is, do you always need Opus? And just to reiterate, Opus is, so this is from the Anthropic family of models. Opus is the most accurate, but it's also the slowest and the most expensive. We're going to ignore Fable for a second. I know those statements don't make sense with Fable, but we're going to ignore Fable for a second. So the nice part is Opus gets you the most accurate responses, but often they're the slowest and they cost the most as well. Sonnet is less accurate, but it's faster, and it's kind of this like middle ground for cost, accuracy, and speed, which is kind of the trade-off that a lot of these models are making. Is do you want it cheap and fast? Well, then it's not going to be super accurate, and that's really where Haiku comes in. So Anthropic has these 3 classes of models of Opus, Sonnet, and Haiku, and Haiku is the least accurate, but it's the fastest and the cheapest. So I'll show an example in a little bit of how you can use like Opus for plan mode. So if you're setting up a plan and having Opus like grill you on any questions of like, hey, you said you want the story to do this, but that's in conflict with this other thing. How do you want me to handle this? Usually you want a higher level model for plan mode to kind of understand exactly what it is that you're trying to execute on. And then once it's laid out the plan, you would use Sonnet for execution. So I kind of liken this to, you have like a tech lead kind of plan out things, and then you kind of hand it off to somebody more junior to actually do the execution and things like that. So that's kind of the concept behind doing that. Haiku can be fine for answering questions, but really don't use it to execute because you're going to have a bad time with that. But something else to think about is Opus is 2.5x what Sonnet costs. So one-shotting with Opus is probably cheaper than 3-shotting with Sonnet. One-shotting meaning you give it a prompt and does exactly what you want the first time. That's probably going to be cheaper than going back and forth with Sonnet 3 different times. There's technically some nuances there of like token caching and things like that. But something to think about is some people are like, oh, I'm never going to use Opus because it's so expensive. Meanwhile, they go back and forth with Sonnet a bunch. It's like, well, you probably could have been better off using Opus for some of your tasks. Likewise, Opus is 5x Haiku, so one-shotting with Opus is cheaper than going back and forth with Haiku a bunch of times. Some other model management tips. Auto mode in Copilot can pick things for you. However, keep in mind that as soon as you pick a model, it's not going to switch it because it's going to break the token caching and things like that. So generally, once it picks a model, it's going to stick with it. So keep in mind your first question that you ask might define what model that it uses behind the scenes. So in general, I don't really use auto mode super well because I just know I've gotten to know these models and kind of know what their trade-offs are. So I kind of pick what I want, the best tool for the job. I mentioned earlier about having Opus be in plan mode. So this is a relatively new feature, I think in the last like week or 2 of Copilot, where you can set a model for planning only. So you can do /model space plan space Claude Opus 5 to have Opus do the planning. If you don't know what to put there for Claude Opus 5, just type in whatever you want. Just type in Opus and you hit enter, and it'll say, hey, Opus isn't 1, but here's the 10 you can pick from or whatever it is. And then you can set your model to Sonnet for execution. Again, if you're trying to balance like wanting a higher level model for planning by default and then a lower level model for execution. So again, want to call out that as a strategy as well. So picking the right tool for the job based on what it is that you're doing. Full disclosure, this was probably a month or so ago. I was kind of just doing my thing with Opus, and I wanted it to create a file that had 1 word in it. And I kicked off Opus to do that, and right after I did, I'm like, I shouldn't have done that. I should have literally just manually created a file with that 1 word in it. So again, being mindful of what you're doing just to make sure that you're using these tokens responsibly. All right. effort management is the next thing we're going to talk about. So higher effort basically means better answers on harder problems, but it takes longer and costs more tokens. So effort is a way for you to tell a model, hey, I want you to be on high effort or extra high effort or low effort or medium effort. Basically, the higher effort you give it, the longer it's going to take to think. So by default on Copilot, it starts everything out on medium. But what's interesting, like Claude Code, for instance, with Opus, defaults the effort to high for Opus. So something that I do is like I assume Anthropic knows how to use their models better than I do because they're trying to trade off like good answers and speed and effort and cost. So I switch Opus to high because I assume that Anthropic knows better than I do. So, but you can basically toggle these things based on the task that you're doing. And a rule of thumb is like, how hard would you think about the problem? AI is probably similar. Like if it's something super easy, you can have a lower effort. If it's something super hard, you probably want to have a higher effort. And again, how effort kind of works behind the scenes is if you think about if you have low effort, you might answer something off the top of your head, which is the quickest and cheap, but it might be missing some extra context or it might not be the right answer because you're just trying to answer it off the top of your head versus like if somebody asks you a question, you go look it up and reread it and fact check. That's obviously going to take more time, ultimately kind of cost you more money. But it leads to a more accurate answer. So behind the scenes, it's doing things like double checking sources and things like that as you make the effort higher, which then will give you better results. So again, it's kind of a trade-off of time, cost, and accuracy. All right. So just want to be aware of effort because a lot of people honestly probably don't change this and just leave it at medium, but that's another knob that you can turn as well. All right. Next three things I'm going to talk about are called Headroom, Ponytail, and Caveman, and that is the actual names of these three tools. So the idea behind Headroom is you shrink the prompt, and I'll talk about how it does that here in a second. Ponytail, you shrink the code, and Caveman, you shrink the output answer. So if you think about it, if you shrink the prompt, you're going to have less input tokens coming into the system. If you shrink the code that it creates, it's going to result in less output tokens, so it's going to save you tokens that way. And like the explanations behind things, if you shrink those, that also decreases your output tokens as well. So if you combine kind of these three tools, you can save on how much tokens you're spending. So if we take this graphic I had earlier, again, this is the exact same graphic. That's the input and output tokens. And if we add a few things here in the middle, so if we make it look something more like this, Headroom kind of gets involved on the input side and does like some compression things and things like that. I'll show an example or talk about that in more detail here in a second. And then on the output side, Caveman is basically giving you tighter explanations of things, and Ponytail is causing you to create less code, which has some benefits of like less output tokens to create, but then when you're reading in the code later, it also is saving you tokens. So the next time you are changing that code on the input side of things, you're inputting less as well. So again, Headroom sits between Copilot and the model, and basically it compresses lots of different things, your conversation history and all that kind of stuff before it gets sent. And usually this roughly saves like 15 to 20% savings in token traffic. There's a company behind it called Headroom, but you can use it for free by default. And basically you say, when you spin up, like let's say the Copilot CLI, you say Headroom wrap Copilot, and now you have Headroom sitting between you and Copilot. Now, obviously this is another product built by another company. So you'll have to talk with your groups on if you're okay adopting this particular tool or not. It does all run local too, so everything stays local to your machine. Ponytail, so this is a skill that makes the agent behave as what they say, the laziest senior dev. So this results in the least amount of code needed to fulfill a task. So you're not trying to plan for a million different edge cases that might not ever happen. You're just planning for the least amount of code needed to fulfill a task. And in their research, it's resulted in about half as less code on average, which then results in 20% cheaper like output tokens, as well as it's also faster because the model's not having to go through and make all of the changes to your system. So there's a link to that, and we'll show the slides afterwards, so you'll have that. And then if you want to look at the actual skill itself, you can go to that link. You can kind of see, and again, literally it says act as if you're the laziest senior dev, and surprisingly that works and causes AI to take on some of those characteristics. So show an example that they've got for like email validation, CSV summing, those kinds of things. Without Ponytail, you had 75 lines of code. With email validation, and with it dropped it down to 3. So again, you can imagine that this is saving you some tokens as well. All right, where Caveman comes in is what they say, and this is from the show The Office, where character Kevin decides he wants to speak in as few words as possible to save time. So Kevin says, why use many word when few do trick? Because you get the gist of what he's saying. And Caveman tries to do the same thing by saying, why use many token when few do trick? So this results in 65% less output tokens. And again, output tokens are the most expensive part of tokens when we were looking at that before. There's a link to that. But to show you an example, like a side-by-side, on the left-hand side, it's saying, hey, the reason your React component is re-rendering is likely because, and like you can see, there's a lot of like fluff words coming back from AI versus here it's just saying, hey, it's new object ref for each render, inline it, wrap in use memo. So it's telling you exactly what the problem is, what's causing it, and how to fix it. So it gets rid of all of that kind of boilerplate of what's coming back. So it doesn't give you like the sure, I'd be happy to help you with that. It doesn't give you any of those kinds of things. It just tells you exactly what it is that you're trying to do. So if you like somebody who's direct, straight to the point, Caveman is the answer to that. So again, if we look back at this, hopefully that makes sense of kind of where things are and where Headroom comes in versus Caveman and Ponytail. So again, Caveman and Ponytail on the output side, Headroom is on the input side. All right, with that, we're going to wrap up with some takeaways. Hopefully you got some understanding of what tokens are. Hopefully you got some understanding of what changed with GitHub's billing, some context management ideas, as well as thinking about token caching, because I'm guessing many people weren't necessarily thinking about that or knew that was happening. Some tips around model management, how you can change the plan mode of modeling of the model that you're using. Effort management, and then the 3 tools, Headroom, Ponytail, and Caveman, to do some explicit token management for you. As an aside, we do have this tool we call the Agent Ready Assessment, and basically the idea behind this is we can point this at a code base and get an assessment of how ready your code base is for agents, because generally speaking, you want different guardrails in place for agents, especially so they don't end up wasting your tokens, because the biggest place where you can waste tokens is if you end up throwing away the code that you had AI generated. Like that's literally the biggest waste of tokens that you could possibly have. So the Agent Ready Assessment helps keep your tokens on the rails and make sure that you're getting the most bang for your buck. It gives you an actionable punch list of things that you can do to get your code base ready for agents. So with that, we'll open it up for Q&A.
Great, Scott. Thank you for that. We really appreciate your time. And the chat is now open for any questions that people may have. In Caveman, that means ask a question.
Make webinar good.
Make webinar great.
Do not see any questions rolling in.
There we go. We got one from Andrew. In model management, what have you seen is best to manage the versions? Opus 4, 5, right away, or wait? Thank you.
Yeah. Yep. It's a good question. So almost always when it comes to those model upgrades, like within the same family of like Opus 4 to 5, they keep the same pricing. So really there's not really a reason to stay on like Opus 4.5 and not, or 4.6 and not switch to the latest 5, unless you have some sort of preference with that particular model. But I mean, eventually I find most people don't, and eventually they're going to like retire those models anyway. So really there's no reason to move. Uh, yeah, Andrea, another question of any security risks you've seen with the versions. Do you mean the versions of the different models? Yes. Okay, cool. Yeah, so on the Anthropic side specifically, so I talked about Opus, Sonnet, and Haiku. There is another one called Fable, which is kind of their latest class of models in a class called Mythos. So one difference between Fable and the other ones is Fable, they think it's so powerful that they want to make sure that people aren't using it incorrectly. So right now, if you have a Copilot Enterprise or Business license, they don't keep your data around. So when you send a prompt to them and they give you a response back, they're not keeping around the logs of what you sent, and they're not training on your data and all of that kind of stuff. Fable is different because they're worried that people are gonna, it's too powerful and people are gonna use it for not good things. So they keep your data around for 30 days and they're analyzing the logs. Now they still have the same thing about not training on your data and things like that, but that has been that's the first model that's been released across any provider that I'm aware of where they've changed how what their logging posture is for those models. And again, it's done from the standpoint of they want to make sure people aren't trying to build like, I don't know, a nuclear weapon or something with the model or something like that. Now, there are safeguards in place for those different models and classifications and things like that that are in place to make sure people are using it for good purposes. So it'll reject if you ask it for using it for nefarious things and things like that. But they want to just like be double sure. So they're keeping the logs around for 30 days to make sure that they're staying on top of that. So that's probably the biggest security risk that we're seeing. So that's causing a lot of clients to disable Fable because they just don't like the idea of their logs sitting around for 30 days, even though, again, they're not training on your data. They're not going to like end up with, you know, your company secrets getting sent to somebody else. But that's really the biggest one that I've seen.
Anything else? We've got 11 minutes. Scott actually got through this really fast. Good job, Scott.
I guess maybe as people are thinking, maybe just touch on the security aspect side of it too. Like I do think there's also, you know, what you allow people to do. You know, you can throw things into like a sandbox locally, which is kind of like a cage that models can't get out of, and they're just scoped to, you know, maybe a particular folder, things like that. So there's a lot of different things that you can do to make sure AI is doing what you want it to, and things like that, and a bunch of different controls in place.
Going once, going twice. Thank you for joining us today. If
All right,
there's any
yeah.
other questions about, you know, what Scott discussed today, please feel to reach out to him. Please feel free to reach out to me. Oh, we have another question. Is there a cost difference when entering a prompt to exclude a task versus having the agent execute the same task, but using instructions from your agent file?
So by default, when you enter in a prompt into like Copilot, for instance, you're gonna send along your instructions file along for the ride if you're in the repository. If you have it like scoped to the repository that you're in. So no matter what, it's gonna send that instructions whether you want it to or not. Now, if you put it into like its own folder where there's no instructions and things like that, yeah, you're gonna save some money because you're not sending your instructions along for the ride. But you know, hopefully your instructions is helping AI craft kind of what response that you want, because a lot of times your instructions file are like, hey, don't do this thing, like don't write code comments for arranged act assert and tests or whatever the case is. So hopefully you get better responses with your instructions, and that's kind of the whole point of instructions. So if you feel the need to like, hey, I don't want to pay the cost of my instructions file because you know, it's too wordy or something like that, that's probably a sign that maybe you want to clean up your instructions file. And there's lots of different strategies for that. You can tell like in the instructions file, like if you got front end and back end code together, You can say, tell your instructions, hey, load this separate instructions file when you're doing backend code, or load this one when you're doing front end code, and not have it loaded all the time, no matter what task that you're doing. So yeah, so there, in short answer, there is a cost difference, but ideally the instructions are also guiding you to get better responses, so you don't have to interact with it multiple times. Because again, interacting with it multiple times is going to lead to higher costs. Anybody else?
Yeah, good question so far.
Well, yeah, cool. If anybody has any questions afterwards, feel free to shoot me or Tim a message afterwards. If it's not obvious, I like talking about this stuff, so happy to answer any questions that you might have. But otherwise, thanks for coming, everybody.